Welcome to Brain Vision.
In this problem, we are given a 3 kg particle in our axes as shown in the figure, and we wish to calculate the angular momentum of this particle h about point O. So the first thing we need to do is write down our position vectors. So the position vector relative to the origin of point B, remember the coordinates of A and B are 2, -1.52 and 330 respectively, and those are in meters. So the position vector of B relative to the origin is 3i plus 3j, and there's no k component, and that's meters. The position vector ROA is equal to 2i minus 1.5j plus 2k meters. Now that we have the position vector, we need the velocity vector for particle A. So the velocity vector VA is equal to the speed VA, and we need the direction which we get from the vector R AB over the magnitude of this vector RAB. And so this is speed 6 meters per second, all multiplied, and RAB is 3 minus 2 in the I direction plus 3 minus 1.5 times unit vector j plus 0.2 times unit vector k. And all of this over the magnitude of this vector, which is the square root of 3 minus 2 all squared plus 3 minus 1.5 all squared plus 0 minus 0.2 all squared. This is actually 0 minus 2 and not 0.2. So that's 0 minus 2k hat and 0 minus 2 all squared. So if we calculate this, we get the vector v, the velocity for particle A, to be 6 over the square root of 25.25 I plus 27 over the square root of 25.25 j minus 12 over the square root of 25.25 times k. And that's our vector velocity. Now that we have the vector velocity and positions, we can find the angular momentum about point O. So the angular momentum about point O, h, is the position vector ROB crossed with the linear momentum m, the mass of the particle, times its velocity VA. And so if we use the cofactor method, we can write this down as follows. So we want our I, j, and k components. And for ROB, this is simply 3, 3, and 0. And for MVA, it's m times our velocity vector VA, which is 6 over the square root of 25.25. The j component is 3 times 27 over the square root of 25.25, and the k component is the mass 3 times minus 12 over the square root 25.25. So if we perform this cross product, we find that the angular momentum about point O is minus 21.5 I plus 21.5 J plus 37.6 K, and this is in SI units of kg meter squared per second.